Okay, so on the 45 to base 7, and it says to do it mentally, you don't have to. You can work it out, but you can do it mentally though. Here's how you do it. 7 goes into 45 how many times? Okay, 6 times. With what left over? 3. So this is the answer in base 7. One more time, guys. We take 7, this is division. We divide it into 45. 7 goes into 45. How many times? 6 times. 6 times 7 is 42. You subtract 42 from 45. That leaves you with 3. Okay, so the answer is 6 and then 3. And that's it.
Wow.
I know. All right, so here comes the next one. So on this one right here, you are doing subtraction. When you're doing subtraction, you cannot subtract this 3 from the 1 because the 1 is less than the 3. So you want to borrow 1 from the 3 over here, guys. So this is going to become 2. Now, here's the catch. That 1 that you borrowed is equivalent to the base. And since the base is 4, you're going to take 4 and add it to this digit that was already there. So the 1 will now become 5. Once again, the 1 that you borrowed is equal to the base. The base is 4. So then you add it to the 1 that was already there. So it becomes 5. And now you can carry out your subtraction. So 5 take away 3 is 2. 2 take away 1 is 1. And there's your answer. 1, 2, base 4.
What do you mean by the 1 that we borrowed is equivalent to the base?
Okay, let me go back to base 10 subtraction. In base 10 subtraction, if you had 65 and you needed to subtract 27 from this, back in grade school, we learned we cannot subtract 7 from 5 because 5 is less than 7. So we had to head over to the 6 and borrow 1 from 6. So the 6 would become 5. What would the 5 here become? This is grade school math, guys. What would the 5 become?
When you were showing us that, I was like, wow, if that was grade school.
That's funny. You mean you're like, wow, I didn't learn this in school? Okay, the 6 is in the 10th place. So that 1 that you borrowed is actually 10. So you would take the 10 and add it to the 5 that was already there. So this would become 15. And then you subtract. So 15 take away 7 leaves you with 8, and 5 take away 2 leaves you with 3. That's how you did it in grade school. So it's a similar process. Okay, in grade school, up to now, you've been talking about base 10 numbers. Whenever you think about numbers, you think about these numbers in base 10. But wait a minute, what about the numbers in other bases? In this case, base 4. So just like in base 10, when you borrow 1, it's equivalent to 10. Same thing here. When you borrow the 1 from the 3, it's equivalent to the 4, to the base, which is 4. So you take that 4 and you add it to the 1 that was already there. So 1 plus 4 gives you 5. So this digit 1 becomes 5. Does that make sense now?
I'll have to practice.
Okay, Denise says, no, I'm still confused. Okay, let's try this one more time, Denise. You know what? Let me go back and look at a couple of examples with you, other examples with you. Okay, so let me see here. Subtraction, subtraction, subtraction. Okay, so here's a problem. Let's say you have 4, 5, take away 2, 6. Oh, wait a minute, I'm doing the wrong thing. I'm sorry. Okay, let's say you have 3, 2, and base 4. Okay, and you're taking away 1, 3, and base 4. Is that the same problem we just had? No, it's not. Okay, so Denise, look, you cannot subtract 3 from 2. Right. We agree on that? Mm-hmm. Yes?
Yes.
Okay, So we're going to go over here, Denise. We're going to borrow 1 from the 3. We're borrowing 1 from 3. So 3 becomes 2. Okay? That 1 we borrowed is equal to the base. Just like in base 10, when you borrow 1, it's equivalent to the base. And because you're in base 10, it's equal to 10. But now you're in base 4. So the 1 that you borrowed is actually equal to 4. So you take the 4, you add it to the 2 that was there. So now this 2 becomes 6. Is that starting to make sense to you now?
Yeah, I get it now. Okay.
Okay, so now you can carry on with your subtraction, because you can definitely subtract 3 from 6, which leaves you with 3. You can subtract 1 from 2, which leaves you with 1. And there's your answer.
I didn't realize you meant the number. Okay, I get it. Okay.
Okay.
There's another question that on the second homework that I got wrong and don't get it. I don't get why I got it wrong. Do you want me to read it to you?
Yeah, you can.
It's a 4-digit number this time. So
it's a 4-digit number this time. Okay, hold on a second. Let me finish writing this one. It came from the chat. All right, go ahead. Give me your 4-digit number.
It's 2020.
No.
Plus 1022 base 3.
Okay, 2020 plus 1022 base 2.
No, they're both base 3.
Okay, I was gonna say base 3. Okay, let's do this one first before I do the subtraction, okay? Because this one's easier. All right, so I'm gonna add 0 plus 2. And 0 plus 2, that's 2. There's nothing wrong with that because 2 is less than the base. So I'm gonna drop the 2 over here. Now I'm gonna add 2 plus 2, this column right here. I'm adding 2 plus 2, that's 4. 4 is greater than the base. The base is 3, and we have 4. We cannot use it. It's just like saying 5 plus 6 is 11. We can't use 11 because we're in base 10, and 11 is greater than base 10. So you would have to convert that, okay? So same thing here. 2 plus 2 is 4. You got to convert that. This is why it's worth it to figure out how to do these mentally. So since we're in base 3, we're going to convert the 4 to a base 3 number. So you simply do this. 3 goes into 4. How many times? Once. With what left over? 1. Okay, talking about 11, but this is not 11. This is 1, 1. So you drop 1, carry 1, and then you add 1 plus 0 plus 0. That's 1. And then you add the last digits, 2 plus 1. That's 3. When you have your answers to these problems right here, guys, the answer cannot have a digit that's equal to or greater than the base. So all the digits and the answer must be less than the base. So you cannot use the 3. So you got to convert the 3. So 3 goes into 3 how many times? Once. With what left over? 0. So this is your answer in base 3. How you doing, Denise?
Good, I think.
Okay. All right. So this question was asked in the chat. I forgot who asked this question. Let me see here. I don't remember who asked, but whatever. So guys, on this one right here, we're going to be subtracting. So this question came from Erica. So on this one, yes, we can do 1 take away 1. That's 0. We're good. But guys, 0 take away 1, we can't do that. Here it is again, 0 take away 1, we can't do that. So we got to go all the way over here and borrow 1. When we borrow 1, what do we have left over? 0. Let me see here. Did I write this one wrong? Let me see here. Erica, you sure you wrote this one right?
You added too many ones on the bottom.
You see? Guys, you can check these on your own, okay? Very good, Erica, very good. All right, so guys, here's what I did. I went all the way over here and I borrowed the 1 over here, so this becomes 0. This 0 right here, remember, whatever you borrow is equivalent to the base. So what will this 0 become over here? 2. Are you guys with me?
I'm not really. Just
You're not getting it?
I am.
Okay, I heard on I am. All right, so I think that was Denise. Denise, listen, we have a 1 here. Whenever you borrow with these numbers and other bases, you're borrowing the base. What is the base here? 2. So the 1 that you borrowed becomes 2 over here.
Oh yeah, no, I got that part. I was just wondering.
Okay, what part didn't you get?
How you have the 0 over here to the right, but then you're on the left over here. I don't.
The 0 right here?
No, the right, the one on the right. The
Right
bottom.
here?
No, on the bottom, like the answer.
Oh, okay. All right. So let me go ahead and erase that, and I'll come back to it in a minute, okay? All right, guys. So let's go ahead and keep going. So here, we're going to have, here's a 0. We need to subtract over here. It just erased it, guys. I'm sorry. Okay, we need to subtract that. Okay, and that's a 0. In order to subtract 1, I mean, we can't subtract 1 from 0, guys. So we're going to have to change that. So here we go again. Okay, we have a 2 over here. We're going to borrow 1 from it. So this 2 is going to become 1. And this 0 right here will become what? 2. I wrote this one too close to the top. Okay, so now we can carry on with the subtraction. Okay, we're subtracting, Denise. So Denise, 1 takes away 1, Denise. That's what happens. 1 take away 1 is 0. That's how we got the 0, Denise. And then over here in the second column, 2 take away 1 is going to give you 1. And then last but not least, you could do 1 take away 1, but that's going to be 0. And since it's a leading 0, you do not need that leading 0 there. So there's your answer. All right. Yeah, I can feel it. Some of you are just so confused right now. Okay, ask the question, guys. No question? All right, everybody. So I am going to go over the multiplication and division, and this may help you to clarify some of this. Okay, good, Erica, I'm glad. Okay, so let me go into multiplication, guys. Multiplication in other bases. Remember, this is on the test next week. Multiplication in other bases. All right, guys. So let's chat. So let's see here. When you're doing multiplication in other bases, guys, it's just like addition. Remember, multiplication is a form of addition. It's just repeated addition. So when you do these problems, remember all your answers must have digits that are less than the base. And if you do the multiplication, you end up with a number that is greater than the base, you must convert it. So in other words, you must convert as you go along, guys, okay? So I am going to do a basic problem that you guys did back in grade school just to have you recall what it's like to do multiplication. I'm gonna do a 2-digit multiplication with you guys, okay? So let's say back in grade school, you had this problem back in grade school, guys. 32 multiplied by 23. I'm just making this up as I go along. This is what you did in grade school, guys. 3 times 2, you know what? Let's do a different number. Let's put a 4 here. 3 times 4, that's 12. So you drop the 2, carry 1. 3 times 3 is 9. 9 plus 1 gave you 10. You guys are good? Okay, now, I don't know if I have any elementary education majors in here, but listen, you got to stagger the numbers, guys, stagger, okay? I'm going to show you something that I hate when people do that in elementary school because it confuses students. This is staggering multiplication. So 2 times 4 is 8. The 8 is lined up with the 0. Now, guys, listen to me and listen well. I know a lot of elementary ed teachers will put a 0 here. That is wrong. That is so wrong on so many levels, people. Please don't do that if you're an elementary ed major. If you put that 0 there, you're creating a brand new number, okay? Show the staggering in the multiplication, all right? And then 2 times 3 gives you 6. And what do you do after that? You add. So you bring down your 2, 0 plus 8 is 8, 1 plus 6 is 7. Guys, the process with multiplication and other bases is the exact same thing, all right? So let's go ahead and look. So I am going to go ahead and get started with an easy problem, okay? 2, 5 base 6, and I am going to multiply by 4 base 6, okay? Remember, all the digits in the product must be less than the base. Furthermore, if you multiply, you get a number greater than the base, you got to convert it. So guys, here we go. 4 times 5, that's 20. 20 is greater than the base. We got to convert that. How do we convert that? 6 goes into 20. How many times? We're doing division. 6 goes into 20 3 times. With what left over? 2. So you drop the 2, carry the 3. All right. Next, 4 times 2 is 8. 8 plus 3 is 11. 11 is greater than the base, so you got to convert it. 6 goes. The base is 6, guys. 6 divided into 11. How many times? Once. With what left over? 5. So here's your answer, guys. Okay, take a moment, look at this, and see if you have any questions. I'm going to do some additional examples, okay? That's the first example. I've got 2 more to do. All right, guys, here's another one. Number 2. This time I'm doing 6, 2, 3 base 8. And I'm going to multiply it by 4 and base 8. All right, everybody, you ready? Here we go. 4 times 3, that's 12. 12 is greater than base 8. Guys, if you have a question, drop it in the chat. So I'm going to convert that. 8 goes into 12. How many times? It goes into 12 once. With what left over? 4. Drop the 4, carry the 1. We're going to do it again. 4 times 2 is 8. 8 plus 1 is 9. We cannot include the 9, guys, because it is greater than the base. So you got to convert it. 8 goes into 9 how many times? Once. With what left over? 1. So you drop 1, carry 1. And then last but not least, we do 4 times 6, which is 24. 24 plus 1 is 25. We have to convert that. So 8 goes into 25 how many times? 3 times. With what left over? 1. So guys, here's your answer in base 8. And guys, those are the problems you're going to see on the test next week. Talk to me, guys. Ask me a question. You guys should be feeling comfortable with this part. Because once you get over the addition and the subtraction, guys, multiplication becomes easy. No questions?
I just want to know why I understand this so well and I couldn't do taxes. I seriously don't get it. Like, this is like, I feel like I know this already. And like my taxes, I went, you know, all the examples from the last chapter, like I went over and over it. I don't know what I was doing wrong. I don't understand how this is easier for me.
The taxes are complicated though, they are. And you're dealing with larger numbers. And furthermore, most people don't even do their own taxes, so they don't even know what's going on behind the scene. And if you do your own taxes, it's all done on the computer. Taxes are complicated. Why do you think people hire professionals to do taxes?
Oh yeah, I don't do my own taxes. I have never done my own taxes, nor will I.
Actually, you know what? Most Americans can do their own taxes. It's just that they're afraid to. They're afraid that they will make mistakes and the government will come after them. That's why they don't do it. But most Americans can do their own taxes, guys. It's serious. With all this technology, they've made it so easy for you to basically file your own taxes. All right, guys. This one right here, definitely on the test. This is the third example. So let's do it, guys. We're multiplying 3, 2 base 4 by 2, 3 base 4. So we're going to stagger the multiplication just like I showed you with the basic multiplication problem from grade school. So guys, on this one, we're going to start off with 3 times 2. Okay, let me see if I can use different colors. 3 times 2. 3 times 2 is 6. Can we use the 6? No, we got to convert it. So we're going to convert that to base 4. 4 goes into 6 how many times? Once. With what left over? 2. So you drop the 2, carry 1. All right? So we're going to take the 3 and multiply it by 3. 3 times 3 is 9. 9 plus 1 is 10. We can't use the 10. We got to convert it. 4 goes into 10 how many times? 2 times. With what left over? 2. So you drop the 2. All right, so that was the first part of the problem. Now let's move on to the second part, okay? So we're going to take the 2 here and multiply it by 2. 2 times 2 is 4. Now that 4, guys, we can't use it because it's equal to the base. So we have to convert it. 4 goes into 4. The base goes into 4, guys. 4 goes into 4 once with 0 left over. Now we got to stagger the multiplication, guys. So the 0 goes here and then carry 1. And then let's do it again. 2 times 3, 6. 6 plus 1 is 7. We got to convert the 7. All right, 4 goes into 7. How many times? Once. And with what left over? 3. So this is going to be 1, 3. Now, guys, let's add. Just like we did in grade school. Bring down the 2. 2 plus 0 is 2. 2 plus 3 is 5. We can't use the 5. We got to convert it. 4 goes into 5 once. With what left over? 1. So you drop 1, carry 1. You add, you get 2. And guys, just like that, we are done. So the question you need to ask yourself is, if I see this one in the test, am I going to be able to do it? Okay, sounds like a yes. You guys are going to be okay with that. So if that's the case, then what I would like to do now is to go ahead and move on to division, guys, because it is getting a little late. So with the division, guys, listen well, okay? When you go into the assignment, they will have these charts in the assignment, and I'll go in and show you one of the charts. But when you're taking the test, oh, wait a minute, the test is going to be online, so you might be able to use the charts. But when you're in the classroom, you're not going to have the chart available to you. So you need to know how to do this without the chart, guys. So let me show you how to do it. Okay, I'm going to give you some steps, actually. Step 1, you're going to convert to base 10 first. Convert to base 10. And then step 2, you're going to carry out the division, the process, in base 10. So basically do the work in base 10, guys. And then here's what I want you to do. Number 3, convert back. Convert back to the original base. This is the easiest way I've found to work out the division problems, because when you do the division problems, guys, in the classroom, you have the test in front of you. They will not give you a chart. You are simply on your own, okay? So guys, what in the world am I talking about? Let me go ahead and start with a basic problem, okay? So this one right here, it's 2 base 4 goes into 100 base 4. Now listen, you don't say 2 goes into 150 times. No, okay? So here's what my steps recommend you do, guys. So since the 2 is less than a base 4, we're just gonna keep the 2. So we're going to go in base 10 now, okay? We're converting 100 base 4 to base 10. Now guys, listen, this is really good practice for converting numbers in other bases to base 10. Remember we talked about this last class. So the 0 is in the 4 to the 0 place value. Okay, since it's 0, when you multiply it out, it doesn't matter. This 0 right here is in the 4 to the first power place value. It doesn't matter, just get rid of it. But the 1 is in the 4 to the second place value. And what is 4 to the second? 4 to the second is 16. 16 times 1 is 16. So what did I just do? I converted the 100 base 4 to base 10, guys. So now in base 10, what do I have? 16 divided by 2. Everybody can do 16 divided by 2. 16 divided by 2 is what, guys? 8. But we're in base 10. So now the third step is to take this 8 right here and convert it to base 4. How do you convert this to base 4? You divide, guys. 4 goes into 8. How many times? 2 times with what left over? 0. And there's your answer. Just like that. So I took the 100 base 4. I converted that to base 10 using multiplication. So it became 16. So then I carried out the division in base 10. 16 divided by 2 is 8. I'm still in base 10. And then I take the 8 that's in base 10 and I convert it to base 4. Yes, guys, it works every time. Now, if you really want to get complicated, guys, some of these, they have remainders. Did you guys hear that? Some of them have remainders, okay? So guys, here comes the next problem, okay? 134 base 5. We're going to divide it by 4 base 5. All right, guys, let's do the conversion. We're going to convert the 134 base 5. 4 is in the, oh, I'm doing the wrong thing, okay? This 4 represents 4 to the 0, and 4 to the 0 power is equal to what? It's equal to 1, guys. 4 to the 0 power is equal to 1, all right? Now I'm gonna do it the long way, so pay attention, guys. This one is in the 4 to the first power. 4 to the first power is just 4, and then the 1 is in the 4 to the second place power. So for this one, guys, we're gonna do 1 times 4 to the second plus 3 times 4, and then plus 4 times 1, okay? Put that into your calculator and figure it out. So this one is gonna be 16 plus 12 plus 4. 16 plus 12 plus 4 is going to turn out to be what? 20. Oh my goodness, I did it in base 4, guys. This is supposed to be in base 5. Wow, you guys didn't even say anything to me. Shazam. I just realized that, guys. I did this in base 4. We are in base 5. Nobody said anything. Are you guys not paying attention?
I was busy writing and then just realized.
Okay. All right, guys. So let me fix that. I'm going to rectify it. The 1 represents 5 to the second. The 3 is in the 5 to the first power place value. And then the 4 is in the 5 to the 0 place value. Okay? You're going to grab your calculator, guys, and put this on your calculators. Okay? 5 squared is 25. 3 times 5 is 15. 5 to the 0 power is 1. So 4 times 1 is 4. You add it all up, and this is going to turn out to be 44. So that 134 base 5 is actually 44, guys. So this is where we are. We are in base 10 now. This is base 10, people, base 10. So let's carry out the division in base 10. 44 divided by 4 is 11. We're still in base 10, guys. This is all base 10. Now we're going to convert this to base 5. How do we convert it to base 5? We just take the 5 divided into 11. 5 goes into 11 how many times? 2 times. And with what left over? 1. So here's your answer, guys. 2, 1. See, I could have done that in my head, but I'm writing it out for you guys to see what's happening. So 2, 1, base 5 is your answer. 21 base 5, that's your answer. All right, I feel like you guys should be asking me a question, but you're not asking the question probably because you're overwhelmed and you're a little confused, you're lost. So guys, somebody just ask a question already. I'm gonna do a couple more, by the way.
I have a question about the homework.
Mhm.
I couldn't get this one. Give me one sec.
Is it about the division?
Yes, ma'am.
Okay, go ahead.
Let me see if
Find
I
it
can
and
find
give it to me. It might be one of the questions I'm about to discuss with you.
Okay. Just one sec.
Okay. Now remember guys, you will see some remainders in your assignment. All right, you didn't find it?
It's the one with the chart. It's 2, 5.
That's what this is. That's what
Yes.
this is. Because listen, the charts aren't available to you every time you do one of these problems. When I go on the assignment, I will do the chart question. Actually, you can even share your screen with me and I'll show you how to do it. So what I'm trying to tell you is you can do this without using the chart. And I'm giving you the steps how to do this without using the chart, okay? You have one of two options if you're doing a problem like this on a regular test in the classroom. Either you create your own chart or you do it without a chart. So what I'm doing is showing you how to do it without the chart, okay? So like this next one right here, 224 base 5 divided by 3 base 5, guys. Okay, let's convert this number. This 4 right here represents 5 to the 0. This 4 represents 5 to the first power. This 2 right here represents 5 to the second power. So guys, let's convert it. When you convert it, you're going to do 2 times 5 to the second power, which is 2 times 25. And then you're going to add 2 times 5, and 2 times 5 is 15. And then you're going to add the last digit, 4 times 5 to the 0. Now 5 to the 0 is 1, people. That's 1. You know what? I'm just going to put a 1 over here, guys. Just put a 1 over here for me, okay? And so that's going to become 5. So 2 times 5 is 50. 50 plus 15 plus 4, guys. That's going to give me 69. Are you guys okay with that? Now, how in the world did I get 69? Aren't I supposed to get 60? Let me see, 50. Plus 15, that's 65. It is 69. Okay, I made a mistake somewhere, guys. Oh my goodness, I see my error.
I got 64.
Yes, I know it's 64. You know what it is? I put 15 here. That should have been 10. 2 times 5 is 10. I put 15. Shazam, 64. All right, guys. So this is in base 10. So now we're going to take the 64 divided by 3. 3 goes into 64, guys. Let's do the division. 3 goes into 64. How many times? Okay. Let's do it the long way. 3 goes into 6, 2 times. 2 times 3 is 6. We subtract, we get 0, bring down the 4. Now, 3 goes into 4, how many times? Once. 1 times 3 is 3. 4 take away 3 leaves you with 1. That's a remainder. This one has a remainder, guys. There's a remainder. Okay, but wait, we're not done, okay? So this turns out to be 21 remainder 1. The remainder, we're going to carry it over. Now, we need to convert this right here, guys, to base 5, the base we started with. Let's convert it to base 5. How do we convert that to base 5? 5 goes into 21. How many times? 4 times. With what left over? 1. That is in base 5. And then you add your remainder at the end, just like that. And guys, we're done. Yeah. Okay, do you guys feel like you need another example?
I still didn't get my question answered. I just mentioned the chart because that's what's like in the question. I just need help with problem number 10 in the second homework. It was like 133 base 5 divided by 25. And I didn't know how, like, I kept getting the answer wrong.
Okay, it's 133, not 135. When you guys say, okay, 133 base 5. When you say 133, you're implying base 10, okay? So 133. And then you're dividing it by what? 3 base 5 or 2 base 5?
2 base 5.
2 base 5? Okay, let's do it. Okay, so you got 5 to the 0, which is 1. This is 5 to the first power, 5 to the second power. So basically, when you convert this, you're going to do 1 times 5 to the second. 5 to the second is 25. And then you're going to do 3 times 5. That's 15 for sure. And then you're going to do 3 times 1. Okay, you see how I'm writing 133? Okay, I'm multiplying it by its place value. So I get 3. I add all this up together. So I'm going to get 43. Okay, so this is in base 10. You take 43, you divide it by 2 and base 10. Okay, so 2 goes into 43 21 times with a remainder of 1. Are you okay with that? 43 divided by 2 is 21 with a remainder of 1. You good with that? We're not done. We're not done. Okay, so now you're going to take the 21 and you're going to convert it back to base 5. Okay? So 5 goes into 21. How many times? 4 times. With what left over? 1. And this is your answer with a remainder of 1. And that's it. So you do not have to rely on the chart to do this problem. Did you get it?
Yeah, my bad. I'm just writing it down.
Oh, okay. All right, guys. So I think I'm gonna leave these numbers in other bases so I can close out this chapter. There's one more lesson in this chapter, and this one last lesson, guys, has to do with the Roman numerals, okay? Where we study the Roman numerals and how to use them, okay? The Roman numerals, guys, most of the time we don't even use them. When do we use them? Most often during Super Bowl season. So the Roman numerals includes I, which is 1, V, which is 5, X, which is 10, all right? L, which is 50, C, which is 100. By the way, most of you are familiar with the first 4 because of the Super Bowl. But C, most of you are not familiar with that. D is another one that people aren't familiar with, 500. And then M, maybe some of you might be familiar with this, okay? That's 1,000. All right, guys. So let's talk about how we work with the Roman numerals, okay? So if you have a large number, followed by a small number, you add. Ooh, I like the way I'm writing this. Here's an example, guys. LX. L is a large number, that's 50. X is a small number, so we're gonna add it. So this number represents 60. All right? Now, next part of this. If you have, let me see here. Okay, let's do this. If you have a large number preceded by a small number, in other words, you have a small number in front of a large number, then you're going to subtract. Okay, so guys, what in the world am I talking about? XL, Shazam, XL. X is smaller than L. So you're going to have to subtract 50 minus the value of X, which is 10. So this is actually 40. So when we talk about, you know, clothing sizes, and we call it an XL, okay? I know XL stands for extra large, which I don't necessarily agree with because the word extra uses EX, but whatever. Semantics, guys. Okay. So that's the first part, guys. Next, when you're dealing with Roman numerals, guys, you cannot use a Roman numeral more than 3 times consecutively. You cannot use a Roman numeral more than 3 times consecutively. So if you wanted to write the number 40, you cannot do X, 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 X. No, you can't do that. You can only use a Roman numeral up to 3 times consecutively. So if you wanted to write 30, you can do XXS 3 times. If you wanted to write 3,000, you could do MMM 3 times and get 3,000. That works. That's good. But if you wanted to write the word 40, I mean the number 40, you can't be using 4 X's. You have to make sure you use subtraction like I just showed you. Okay? So now, guys, the big question is this. How do I remember which one is which, especially when you're in the classroom? Everybody's familiar with IVXL, but C, D, and M, people aren't familiar with that. Okay, so here's the plan I've devised for you, okay? So C, to remember C, I'm thinking about century. A century is a period of 100 years. And then for M, I'm thinking of millennium, guys, millennium. Millennium is a period of 1,000 years. And then I have no clue what to do with the D. So here's my suggestion for the D. Alphabetically, D is in between C and M. So numerically, we'll say 500 is between 100 and 1,000. Hello. Okay, guys, that should help out. Okay, so that's the set of numbers we're going to see in lesson 4.4. And then additionally, guys, we do have the Egyptian numbers. The Egyptian numbers, I'm just going to mention it here. We're going to see these. The one that starts with the staff, which represents 1. Then you got a heel bone, which represents 10. And then there's lots of other characters too. I can't remember the entire list. When you see this on the test, whether it's on the test online, in the classroom, on the final exam, you will get the chart for each one of these. But guys, let me just say this. For the Roman numerals, you will not get a chart. There will not be a key. Egyptian numbers, you will get a key. I will go over this with you when I go into the assignment. I just want to mention these Egyptian numbers are coming up, okay? And you need to know how to work them out. Okay, there's a number for 100. I don't remember all the characters, guys. There's a number for 1,000 and there's a number for 1 million. I always remember the 1 million. Why? Because it's an astonished person. And this person is astonished because they believe they just won $1 million. Hello, okay? I don't have all the other characters, the characters in between, because they have a tadpole. And then there's another one, I don't remember what it's called, a pointed finger. I think the pointed finger one is the one that's 100. And then the tadpole, I can't even sketch that out, guys. I'm telling you, it's a tadpole. It looks something like this, okay? That one represents 1,000. These are the Egyptian numbers. How do you work with them? Basically, you're just adding up. So if you wanted to create the number 40, you would do 4 heel bones. 1, 2, 3, 4. That's 40. Yeah. So if you wanted to do 44, you would go ahead and add 4 staffs. That's 44, okay? So you're just repeating the same number over and over again, however many times you need to use it. And just like that, guys, we're done with this. I am going to go into the assignment and look at some example problems with you all, okay? So let me go ahead and stop this recording right here.